We will start the first lecture, that is on Introduction to Client-Server Systems, Internet and WebGIS Technology. So there are three components over here: client-server and Internet and WebGIS. These all are interconnected. First of all, we will be talking about something about client-server, Internet. So most of you may be aware also how this Internet works. It has revolutionized the current world in this pandemic situation also through online platforms. So internet is providing that platform wherein we can share the information, we can share the knowledge. So it has become a big tool in the current environment. And WebGIS, again, it is integrated into this environment, and how we will see how we can use this GIS technology over the internet environment. So the content of this session will go like this. I will be talking about the client-server architecture, how it works. What do we mean by a client and what do we mean by a server? And how they get connected to each other. But then, a definition of WebGIS in this environment, how GIS is related in the client-server environment or in the web environment. Then we will also talk about the WebGIS architecture. So basically, earlier we used to have a monolithic architecture. Then later on, the latest one is the service-oriented architecture. Means wherein all the data and the processes, they are available as a service, and we can utilize these services for developing any WebGIS application. We will be talking about the two things on these aspects also, and what are the various components of WebGIS. This is also very important because whenever we are going to develop a WebGIS application, we should be aware that these are the basic elements, these are the building blocks of a WebGIS application. So we will be talking what are those building blocks from which a WebGIS application can be built up. Then we also talk about, on detail, we will be talking about the geospatial web services. So there, as I told you in the inaugural part also, like Open Geospatial Consortium. So this is the organization which is developing standards for the WebGIS environment. Like ISRO is there, which develop the standards for various applications. See, in similar line, we have OGC also. It is similar to ISO only. OGC, this creates standards for the GIS or for the web application or for geo web applications. Now there are some standards like WFS, Web Mapping Services, Web Feature Services. We also talk about some of the WebGIS data format like GeoJSON, XML or the KML part. Then we will also have one use case of WebGIS. So I will be taking an example of ISRO Bhuvan Geo Portal, or one more example of very popular GIS case study is there, the GIS case study, that is the OpenStreetMap. So along with all these topics, I will be focusing on Bhuvan Geo Portal also. So I will take it as an example to make you understand how this GeoPort or the WebGIS development can be carried out, and how you can utilize even this Bhuvan Geo Portal for your own development part. So we will be taking this as an example at every aspect. I will be taking it. Okay, I will not take it as a dedicated WebGIS portal demonstration. I will be using it in each and every aspect of this session particular. So when we talk about the client-server architecture, what do we mean by client-server architecture? Basically, all the users sitting over the internet, they are the clients, and they have one software component in their computer, that is a browser. It can be a Microsoft Edge, it can be a Chrome, Google Chrome, or it can be a Firefox, Mozilla. Any of these three, or there are many other browsers also. Okay, so these browsers basically act as a client. Now it can be executed in n number of computers as well. So these computers having the browser becomes a client. Okay. Now this browser, it sends a URL to the server. The server which contains the huge, which is a very heavy, we can say high-end hardware component, along with some optimized software as well, web software. I will be talking about those web softwares also. So now the server receives, it understands what the browser is sent to it, and once it is processed, it sends a response as an HTML page to the browser. Now this browser, it is so smart, it can interpret your HTML page and execute it in the browser itself, so that you don't see the code, you see the directly the information over there. So the browser is used for sending the URL as well as for receiving the response from the server in the form of HTML. It can be a KML also, it can be XML also. There are many now these days that have come up. So this browser understands these HTML codes and produces them in the readable form. Okay, it all happens in the client end only in the browser. Now, if you see it here, secured. It was a very simple case. The user sending the information, server replying it. So, if everybody is there in the internet environment, they all are, we can say, they all have the good wills only, then it works very fine for you. But people are not that much good in the environment. We need to, there are certain clients or there are certain people who can access the web server with some wrong intent. So for that, we need to secure this client server architecture also. So what we do, we install a WAF or the firewall in between the server and the client. Client cannot go directly to the server. First, it will come to your web. Web means firewall. Web access firewall. So once the HTTPS request, it comes to the web, it scrutinizes it, it reads it, whether it is okay or not, and when if it finds it okay, actually we create certain rules inside this web. It is one table is created in this firewall which reads all the requests from the client, and it forms and based upon those rules which are created in this web, it passes it further to the server. So your application or your data becomes secured in this case. Okay, so HTTP request is passed to the server, it creates the output and gives it back to the response as a HTTPS response to the client in the same format, like it can be an HTML, it can be an XML. If you see it here, something XML is written over here. So this is a very popular language in the web environment, which is used for creating such kind of rules and other data exchange mechanisms also. Okay, so we will see later on all those aspects also. Now, what happens inside the server here? So browser, it can be from a computer, it can be from a thick client, or it can be from some mobile phones also. It can be from anywhere. So they all can make a request. It enters the firewall. The firewall scrutinizes the request. It sends it to the web server. Now your server contains one software also that is called a web server. There are many web servers which are available in the market. One or two I have written over here, Apache or Internet Information System. This is from Microsoft. Okay, so your hardware, it contains one software as well. We call that software as web server. So there are certain rules which are set in this web server also. It can because the request can reach to the web server only through a secured mechanism. It is not like all the request is going to handle. So there are certain software ports also through which web server receives the request. So this software receives the request. Now once it receives the request, if it passes that request to the application server. Okay, now this application server is again which receives the request from web server. It can take the data from the database server, or if it is a static file or the data which does not changes, it directly serves it to the web server, and then web server gives that as a response back to the client. Now, if the request is dynamic in nature, dynamic in the nature means a person is sending some bounding box of a area. It is he is sending it. He is not asking for some information to be fetched from the server, but he is sending some bounding box and asking the web server, you please fetch the land use map on this bounding box to me. So it is sending some request. So it becomes a dynamic request. So user sending some information from his side as well to the server, and server is passing it on to the application. Application is reading those bounding box, and it is getting those values or those land use map. For example, I am saying from the database server, producing the maps in the form of HTML and giving it to the web server, then web server gives it back to the client. So we can have both static as well as dynamic request. The static request maybe user just want to see IRS website. Simple, irs.gov.in. He is not sending any request. He is not sending any other parameters along with his request. He is only seeing, I want to see the list of codes. So click it and it is a static request. So all those requests, this application server processes and give it back to web server in the form of HTML, and it produces it. But we can have dynamic requests also. Like I told you earlier, I want the land use map based upon a say certain bounding boxes. So that becomes a land use map. Now again, if we talk, what are the advantages of this client server model? So data protect, that is very important point to be covered over here. That is the data protection with access control enforced by the security policies. So you can protect your data also in the client server module, where you are enforcing who can access the data. Not everyone can access the data. You can enforce the policies in the firewall or in your web server, which allows only a certain set of people to access it. Or how much they can access it, that can also be set. So your data is protected, which does not happen in your desktop based environment there. That although you can keep your desktop in lock and key, but your desktop based computer is solving for the purpose of a single person. It is not like disseminating the data to a large number of user base. So if I want to give the data to a large number of user base, then this web client server environment provides you the data protection mechanism also with access control enforced by security policies. Apart from that, it is also platform agnostic. What do you mean by this? Although your client and server can have different operating system, different clients, they have different operating system. It can be a Linux, it can be a Windows, Mac, anything. Okay, so it does not matter much in this client server environment, because we have the browser which is available in all the operating system and can be accessed through that. So it is platform independent as well, this client server model. Again, it also addresses a large number of user base that can be addressed at the same time. This is again very important advantage of a client server model. But client server model is not everything. There are certain limitations also. What are those limitations? Like overloading or the denial of the services. Suppose I was expecting that my website will be having around 1,000 users or 10,000 users, but the users trying to hit my website or my WebGIS application were 50,000. So overloading. So it went beyond my expectation because it is available in the open environment. So what happens due to that? Due to that, some of the services are not available to the legitimate user. Let us say 50,000 users are there, all may not be very much, all may not be very genuine users. There may be some casual users also. So what will happen if the number of casual users increases, your server becomes overloaded and the services to the genuine user becomes as a denial. They are not able to see those services as well. So due to a very large number of user base, these kinds of problems can also occur in your client server model. Now let us talk about the web server. There are many things. We will talk about web server, we talk about application server also, we talk about database also. So if we talk about the web server, what is the web server? I told you it is nothing, it is just a software component basically. So if we go by the definition, it is a software and hardware both, okay, that uses HTTP. We also put one S also for it, secured, HTTPS, secured, and other protocols to respond to the client request made over the World Wide Web. So you can understand the web server is nothing. It is a combination of both software and hardware, okay, which works on the HTTP protocol in the www environment. Okay. Now there are certain common and top web server softwares also. I am listing it over here because they are also sometimes if you are going to develop your WebGIS environment or the application, then you should have the knowledge of which GIS server is required for me. For which GIS, because your GIS is one particular application. Let me go back to this application over here. Now, if I say my request is a map request, so again it is a separate application. It is a map application. Suppose it is a database application. It can be a map application. It can be some web service application. So there are numerous applications. So I have for different web applications or the GIS server, we have different kinds of web server requirement. Like one we have Apache HTTP server. It is free and open source and it is most widely used in the internet domain. If you find it, so Apache HTTP server is the most widely used. Similarly, we have Apache Tomcat server. This you will be using basically. Okay, free and open source. There is one very popular WebGIS server that is called GeoServer. I will be talking on that also. We have one separate session for that also. So we need to have an Apache Tomcat server in the front end at this point here. Apache Tomcat server software should be installed over here. Then only your GeoServer will work. Suppose you have some other server, then there is a requirement of some other application or other web server. Similarly, we also have Microsoft Internet Information System, which is a proprietary in nature, which we also have a latest one that is called the Nginx or NGINIX. It is also open source. It is very useful. It is very, we can say, efficient in handling a large number of concurrent users. If you have a large number of user base and at the same time they are hitting the server, then this Nginx web server become very handy for you. Similarly, I have the Light HTTP server, which is again free and open source. We also have from Sun Java System web server. Now, where do we use it? How you can select it? You can select it based upon how well it works with the operating system and other servers, because there are some application servers also. So whether it is able to work with that application server or not, that you have to decide upon. You get it from the internet, its ability to handle the server-side programming, because at the server end, I need to develop my application. So whether this particular web server is able to handle that server-side programming or not. Like for example, I take Java programming. I am doing all my application development in the Java programming environment. Then I need this Apache Tomcat server. This HTTP will not work for me. Okay, or Nginx. Now, security and characteristics. How much secure these web servers are. Performance also there is one important characteristic. The publishing, the search engine, site building tools that comes with it. Whether any site building tools are available with these servers or not. So that these are the points which you should keep in your mind while going for a particular web server. Again, now let us come to your WebGIS environment. We will be talking about the definition of WebGIS. Now let us see how this WebGIS is fitting into our client server environment. Okay, so this WebGIS, it fits over here in the same client server architecture. Somewhere here it is fitting here. Okay, so all the things are same. Firewall is there, clients are there, web server is there, application server is there. That I have one more server that is called the map server or the GIS server. Apart from data server, I have a GIS server also. Now what this GIS server will do? It will handle my all GIS related requests from the client. Client is making some requests related to map. Those map requests will be handled by this GIS server. This GIS server can interact with database server also, because sometimes the data is kept in the database in order to increase the performance of the data, to increase the security of the data. So we have a dedicated database management system. So we can keep our data in a database management system. Now my GIS server or the map server can interact with that data repository or the database management system and get the data, fetch the data from there, process it, and give it back to the client. So this is one typical example of your WebGIS. This is the place where your WebGIS server is fitting over. Okay. Now, how it works basically? The same thing. If you talk here, we have different n number of clients, and we have a particular web environment over internet. Okay. Then this internet will interact with your web server. Web server is the front end basically. Okay. Now this will receive all the requests. It will always come through a firewall. One firewall is also over here, which I have not mentioned it here again. So this will receive that request. If the request is related to map, it will go to a geospatial server. What this geospatial server can do? It can take the data either directly from the file, it can take it from the database servers as well, and give it back to geospatial server. It will process it further. Disseminate the data further. So there are certain administrators also, or the internal client applications which are not accessible to the outside world. We can have it there also. I want to publish the map now here. Okay, so I can have administrators at the internal network as well. Okay, for doing all the GIS related work and publishing them to your geospatial server. This can be done. Okay. Now come to the definition of a WebGIS. It is again very common definition which I have also taken from the internet only. A WebGIS is a computer software. I am not talking about the hardware over here. You see, it is a computer software and hardware configuration both together basically. What it allows? Sharing of maps, spatial data, and geographical processing operation throughout one's own network and beyond. Not only in his own network, but beyond it also it allows it. Using common web communication protocol such as HTTPS and WebSockets. WebSockets are also the latest version of the protocols which are used in the internet for very live connectivity. Suppose I send something called map chat kind of thing. I am doing it. Map chat means I have one map and we want to chat based upon those maps, whether that map is good or not, what are the shortcomings of that map. So map chat kind of application can also be developed using WebSocket because there I require a very live connectivity. Live connectivity is required. So that's why we use WebSockets also. So both these protocols are supported. So it is nothing but a computer software and hardware for sharing maps, geospatial data, and geographical processing operations throughout one's network and beyond it. Okay. Now let us go deep into your GIS server also. If you see it here, we have taken it from this client server module. We have gone to this. Initially, we were having the server component only. Then we went inside the server. Where is WebGIS? This is your GIS over there. Then let us go inside this GIS. Now, what is the GIS server handle? It can handle spatial data along with the attribute data. What is your spatial data? Spatial data is nothing but the data with the location information. Means I am saying one example. Let us say a building. So where is that building? At what location? Where is that building? It does not mean the building is at near clock tower. But if you say where is clock tower? Clock tower is near to building. So where is building? Building is near to clock tower. So it cannot go like that way. Each and every entity in the world, they have one unique location address also, which is referenced by the most popular one is the geographical coordinate system. That is the latitudes and longitudes. For each and every building we have it. Okay. So those location information is stored here. That is a very complex structure. Suppose I have a building, then I don't have one latitude longitude, but I have a series of latitudes and longitudes for that building, and that footprint we have the latitude and longitude for that. So that spatial information is very critical to it. So it manages that spatial information, and apart from that, what is there in the building? What is the purpose of that building? What is the height of that building? What is the age of that building? what that building solves, which purpose that building solves. So these all are the attribute information. So they are combined together and they are stored in one database management system. This is called a spatial. This is called, sometimes we call it as a non-spatial data also. Okay, so this is a very optimal or the efficient management system which handles or which manages these kinds of data sets. Another important aspect is the model management. There are certain algorithms also that are specific to spatial database. It is not like I am firing one small query and getting the answer from it. So there are certain models also. Those models can also be managed inside a GIS server. Okay, so model management. So it is both spatial as well as non-spatial data model. They are managed. Algorithm basically, here it is managing the data and this component is managing the processes or the algorithms behind the data making, or behind the decision making. So once these algorithms are there, data is there, based upon that, we develop one knowledge base. So this is called a knowledge management over here. Then, in order to access all these data, process, and knowledge, okay, data, process, and knowledge, we have one dialog management system also over there. The user interface basically, through which your client will access the decision maker, they will access the dialog management. And through this, they access the data set, the model, the knowledge, and information system is given to the user like this, for example. Now there are certain components of this database management of this WebGIS. It is like database server management, application server software, and the hardware. Now let us talk. Having talked about the GIS also, now let us talk what are the basic elements of a web map or a WebGIS. Okay, so the basic elements of web map, they include a web application basically. So I first of all, in order to disseminate the GIS data to the user, I will develop one web application. Okay, in that web application, I can have GIS data as well as non-GIS data also. Like I can have my banner over there, I can put some login credentials for the user. So a web application is required first of all. Then we have a digital base map also. It is not like at the first I will show a blank canvas to the user. I need to show some base maps also. Now these base maps, in current scenario in internet, there are many base maps are available over the internet. One of the very popular base map is OpenStreetMap, written over here, or the Google Maps or the satellite Google satellite. They can also be used as a service in your web application or the WebGIS application, acting as a base map. We cannot perform any task on these maps, but they act as a information map, only information map at the back end, at the background image you can say. Then we have some operational layers also on top of which we work something. Let us say I have a land use map, I have a some water, like example we can say we can have a water quality map, and we want to perform some operations on taking these two, land use map or the water quality map or the weather maps. I want to work on top of this and do my GIS analysis. So these are called the operational layer which works on top of a base map. And there are some tasks and tools also for that. What are those tasks and tools? They are called the interactive element, like panning moving here and there in the map, zoom the map, tilting the map, pop-ups you can do. Pop-ups means you click it and it generates some information for me. So these all can be generated in a web map or a GIS map, we can say. So we can also have one or more geo databases also at the back end in order to do the data security or to enhance the data performance. So we can also keep the data in a geo database. Okay. Now, what are the advantages of WebGIS? Let us talk about that thing. So there are a large number of users, which we have already seen earlier. It has a global reach, irrespective of where the person is sitting. I can disseminate the data to him. Example, let us say Google Geo Portal. It is available all around the globe. So better cross-platform capability, we have seen it. It can work on any kind of operating system, whether it is a Linux-based system or a Windows-based system or a Mac-based system. So we have platform-based capabilities also. It is low cost as averaged by the number of users. Although we have kept a very heavy server at the server end, but the number of users it is addressing. If we divide it, then the cost will be very less as compared to a single desktop-based GIS application. Easy to use. I don't require the client don't require very sophisticated software at their end. They only require a browser and they can do it over there also. Unified updates also. Unified update means once I am updating at the central end, update is getting disseminated to all the people at the same time. All are able to see those updates. Diverse applications. There are n number of applications which can be developed using the WebGIS platform. Now, let us talk about the latest, the modern WebGIS technology. Okay, modern. Earlier, I was talking about the monolithic. It was like I have a web server, I have application server, GIS server, and my data, all GIS analysis work is being done through that kind of scenario, that architecture. I have a modern architecture also for our WebGIS application. So how modern WebGIS is coming into picture? We have something called in the internet domain. We have Web 2.0. This is the technology which has revolutionized the internet domain. What it is doing it is providing the interactive web application. I can also participate. Earlier, the websites were like we can say a particular organization was having the information and they were disseminating it to the user. Now, suppose user also want to put something into the environment. They also want to post their data in the internet. So that is was all possible through Web 2.0. It is referenced as an interactive web or application with public participation, which allows participatory information sharing. Interoperability. This is again very important. Interoperability means if I want to share the data between two organizations and they don't understand each other's language, how they will exchange the data between them? So that was possible through interoperability. How this is implemented? The very important concept is through web services. So, in the concept of web services has been used for this interoperability. It is user-centric design, collaboration on the World Wide Web. So, this all has coined a new term which we call as Geography 2.0 or GeoWeb 2.0. Okay, so the integration of web and GIS data application is known as GeoWeb 2.0. So all those things that have come directly into your geographical environment. So some important components of your WebGIS or the Web 2.0, it can act as a web platform. Web as a platform. Now internet is acting as a platform. These are the conceptual aspect of this Web 2.0. I can use it as a platform for my own applications. I can participate along with my data set. Content syndication. I can take the data from n number of applications and use it in my application. Let us say there are certain number of websites. They have their own data set. I am going to develop my own website, but I don't want to regenerate the information which is already available somewhere. I want to directly use it. Can I syndicate it to my website? Yes. So that is all possible through content syndication. Okay. This is RSS. Really simple syndication. These are the technologies which are providing it. Similarly, we have the concept of web service also. I told you earlier also interoperability. So this is all possible through in this Web 2.0 environment. If you explore it more, you will be having the exciting world of this Web 2.0. What are those concepts? What are the technical aspects of it? Excel, RSS. RSS is really simple syndication. Okay. And then we have JavaScript here. Ajax. This is again one more. This is JavaScript. This is the most popularly used programming interface in the current world. We have one dedicated lecture. It will be very exciting for you to how to use the JavaScript for all these kinds of information. Ajax is there, and so what it is doing actually, it can be realized by combining several web computing technologies like Ajax, API, REST, XML, these all are the technologies which are used for implementing these concepts. I told you over a platform, how it can act as a platform, how I can participate over there, how we can syndicate the content, how we can interoperate with, how can I share the data with different formats. So this is all possible with this kinds of technology available in today's world. Now, full GIS servers are emerging based upon these standards. Open platforms, mapping and visualization, data as a service is also available now today. You can take your data as a service. Whether I can take GIS data as a service. Many data sets you may be using, like ticket, like you can say, make my trip. You might have seen it. You are selecting it, and it is searching the either the railway or the air information with you from their particular website. Okay, I am not this make my trip or some other broker applications. They are not hosting those information in their website. They are fetching it from the parent website. So that is all possible through the services. The same way we can also fetch the data from internet for developing our web application. Let us say I want something from Bhuvan Geo portal. So we will have an example also for it. I want to fetch some information from Bhuvan. Let us see. Okay, we will take it there. Directly we can take that example over here. You can cover it also. So let us take this Bhuvan Geo portal. Now, this is one very typical example of a WebGIS application, we can say. Now, I was telling you that the concept of web service, see how I can use the services from this Bhuvan Geo portal in my application. Now, it is important here, the application need not be a web application. It can be your desktop-based application also. We can take the data from website to my desktops also as a service. So let us take a small example. I will tell you over here. In Bhuvan, we have one component called thematic services. Let us click it here. If you see it here, it is saying also it is an application, it is a web service component. Now here, in this particular section, I have many information or the many kind of data set. Let us say land use map of 2005 and 6. The data is available here. If I say select particular state, Uttarakhand, view, and I am able to see the land use map of 2005 and 6 of Uttarakhand in Bhuvan Geo portal like this. And I want to see the statistics. I can see the statistics also over here. Now, I want to use it as a web service in my application. Let us say I have very popular GIS software is there that is called QGIS. I want or some in applications I will be showing later on. We will show you how we can access the data in my applications also. In QGIS is one software. Let us try to open it here. Now, if you see, it is opening up now. In the meantime, if you see it here, I have 2011 and 12 data set also over there of Uttarakhand region view. You can see the data set of 11 and 12 land use map, land cover map for the entire state. Okay. Similarly, there are some other information also. Like I will show you one more. This is one Bhuvan Geo portal. Let me take you one more application. That is, let us. Many times people are interested. I want the village boundaries by census data. मुझे चाहिए. How to get that one? So for that also, let me go to this slide at the end. I have created one small. It is there only. I will find the application. Okay, no problem. We will see it here directly. It will come here. Geo name GEONER. By the time that QGIS opens, okay, let me see whether QGIS is open there. Yes, QGIS is also open. I will take one more example. Two webs we are taking it here. Get let us say GeoNear. One example we are taking as a web service here. So if you see it here. will open it here for me. Another language for IBM. Let me take it. First of all, I will close it here. Bhuvan only, let us say. I will come back to that one also. So web services here, if you see it here, we have one component here called web service. So once I have selected the data of 2011 and 12, how this is acting as a web service now? If you see it here as a web service, you click at the web service component, it says you can access this data using this URL. If you see it here, this URL is there. Now, by simply copy this URL over here, and you have version, layer name also, and I can go to my QGIS software here, add WMS layer. This is a web service in case of WebGIS environment. Now, I will create one new connection with this website. I will give it here LULC map. Okay, underscore over. Plus some example I have given here. URL, I can paste it over here. And then I will say OK, and then I will say connect. So what it will do, it will connect it to me. See, all the data sets are visible to me over here. But my interest is only on this particular layer. UK, LULC 50K, 11 and 12, 2011-12 data set I want here over here. We can filter it out here. So if you see it here, you click it here, and it will show you the map over here. You select it and add. Then you have to close it. You will see the map in your QGIS environment here now. Here, the map is here now. Okay, but although it always the performance sometimes it becomes an issue. So what I have done over here, I have taken this land cover map of Uttarakhand in my QGIS application. Suppose I want the village boundary also, I don't have it, but it is somewhere available in the internet. Whether I can take it? Yes, I can take it as a service as well. But I was searching you over here. So we have a separate class session for it. I will be covering the same. I will take it to you. How to develop that complete application. I want village boundaries maps also over here. And I want to create an interactive map. Boundaries, land use map, some road network also. So all that method application, we will be giving you a demonstration later on. Okay. I will in other sections because I think much not time is there for this lecture. So I will come back to this part only. Yeah? So that was the strength of the web service I was telling to you. How we can use the data as a service also. If you see it here, we can edit the data over there. We can geo-process. We can apply certain of geo-processing also over there. Cataloging service. That is again the metadata about the data. What is the data? Who created the data? When it was created? All this metadata information can also be a part of a catalog services. So that can be accessed. If you see a typical architecture, let us go further inside to the WebGIS. Very technical aspect if I talk about. If you see there, we have the client. Now this is not the client which is an address. These are the client basically. You are a user. These are the users over here. Now what I can have QGIS, I can have open layer, I can have a leaflet, some maps over there. Then we can make a special request. What is this special request? It can be a WMS, WFS, WCS. These are the special web service requests. Okay. These goes to the Apache Tomcat server. Web server is there. This is the web server basically. Then I have a geo server. I can have a map server also. This is another one more GIS server. Okay, name of that server. Then these are the GIS servers basically. I have a GIS database also. So all these is processed inside it, and this web server gives it back as a response to the client. So these can be accessed like this. Now the service-oriented architecture, if we talk, it is like service. Now, what service provider? Suppose you want to develop your own web server and you want to publish it as a service also. So what you will do? You will create a metadata of your services also, of your data. A metadata need to be created, which will allow the consumers or the users to find it, because I cannot find the data, but with the help of your metadata, I can find those services, and once those services are found, then this service, I can make a request directly to this server, and it will give me the request. It goes like this. service provider. It produces the web services along with the metadata also, the catalog services also. These are published somewhere in the service broker. Now the service, the consumer, they search it over the internet in some applications. Like in the Google we saw it, the service provider itself is working as service broker. They are providing the data there itself. So sometimes we have a separate service brokers as well. Okay, so once this data set is available over to them, then these are these service providers. Okay, this service provider directly gives the data to the consumers. So this is very important concept of service. We will be talking more on this concept later on. Now, for the GIS, what are the various services that we can talk about in GIS? This is the modern GIS architecture basically. Data services, portrayal services, processing services. We have different names for all these kinds of services. These all services are published over the internet. We also have the catalog. Now, the user using these catalog services find those data sets and can get access to those data sets by this different encodings. There are different encodings for GML I can have, XML I can have. So all these allows the data access which is available as a web service. We will be talking more into it in the coming sessions. So I was talking about a web GIS service. So what is a web GIS service basically? We will take an example also over here. We have already taken an example, but we will take another example over here from the literature point of view. Like it is a service, they are self-contained or the self-described modular component of geospatial application, which can be accessed through standard protocols. Standard protocols like HTTP protocol or the web sockets are there, so that can be utilized for them. Then is a piece of code. Web service basically, web service is nothing but a piece of code that runs on the server and can perform some actions in response to a client request. A client is making some request. This is a web service component, executes it and gives the user the desired response. Example, if you see it here, it can receive some bounding coordinates. Yes, and an image format. I want, this is my bounding coordinates, and I want the image in the JPEG format from a client. Draw the map. Now, what this API will do, or the web service will do, it will draw a map image and it will send back the image to the client. The client is making a request of the coordinate, and it is also telling it in which format I want it. So this web service will draw that map for it and will give it back to the client. Another example, if you see it here, we can receive some vector feature coordinate and calculate. What this web service will do, it will calculate the intersection of those features and send back to the client the coordinates of the intersecting feature. Okay, two coordinates I am sending, or I am saying, let us say I am sending one road layer and I am sending one polygon layer. We can say a part, or we can say a bit school layer that is in the form of a polygon, and one road layer, and I want to see which are the roads, which are the schools which are near to my, which are in the vicinity of 10 meters or 50 meters in the road, whether they are something or not, or the motorable road. So these kind of information can be sent to the web service. Web service will perform a intersection of these images, and it can, in the GIS environment, we can say geoprocessing, it will do it, and it will provide the response to the client. So, important consideration for a web services. What are those considerations? The format. It can be an XML format or they are the JSON format. These are the two very technical aspects for issuing the request or receiving the response. It can be an XML, and protocols are HTTP and HTTPS as well. Now, difference between a website and a web service, basically. Okay. So, what is a website? Basically, if we talk about website, it provides HTML pages and forms of human user to navigate and perform the function. What kind of functions like this? Just searching, shopping, interaction. These are some of the functions which are provided to the user in the HTML form. Okay. Front-end user interfaces through the browsers also, like google.com. This is one example of your website. Or IIRS.gov.in, human.nrsc.gov.in. These are some examples of the website. What are the web services basically now? This is not website. operations that can be called to return the information. Some operations it will perform. It is a piece of code, basically, a software code which performs some operation and returns the information. It is invoked automatically through a program. You are not firing it. Your program is firing it. One application you have developed, like in QGIS. QGIS was making that request. Okay. You are not making a request, a software is making a request, or application can also make a request. It can be programmed, basically. Okay, publicly available and standard used by all the programmers. Example, there are numerous for it. Okay, once we have I have shown you one example also of the Goan web service. Components of WebGIS, the modern WebGIS server. We have a database server which handles the database in a secured way, in a very performance enhancement way. We have a map server. We have seen it earlier also. Application server. This is just a listing of all those components of a WebGIS server. Now, there is one more example I was having fun. Now, having talked about all those web services and about those web server component or the GIS component, WebGIS component, let us talk about the Open Geospatial Consortium also. I told you earlier also, this is one international organization which is responsible for developing the standards for the web services, geospatial web services basically. There are different organizations for developing different standards for different kinds of web services, but for geospatial data set, we have OGC or Open Geospatial Consortium, which develops standards for the geospatial data set. What is the mission? In which everyone benefits from the geographic information and services and made available across any network, application or platform, irrespective of any network, any application, any platform, you should be able to use that data set. This is the motto of this particular consortium. Let us say I am keeping my data in certain XYZ format. You want to see it, how you can see it. They are the people who develop the standard so that now this standard, I will implement this in standards in my website, and so that you can access the same data in your format also. And this is throughout uniform throughout the world, throughout the globe. Okay, what are some of the very typical geospatial web services you should be aware? We will talk more on to it. Catalog services like about the data about the data set. Processing services, very popular we have web processing services, sensor planning services, coordinate transformation services from one coordinate system to another coordinate system. I want to cover it. Then web coverage processing system. I have one satellite image. I want to do some kind of processing on top of it. So these processing services are separate for them. So they have standardized their processing algorithms also. I have one algorithm for calculating the, let us say, NDVI, normalized difference vegetation index. One algorithm is there. I am posting that NDVI algorithm in my website, but I want some XYZ people. He did not to write it separately. He should access it directly. So I can import, I can implement my algorithm or the processing in a web processing service, as a web processing service, so that anyone over the internet can access it and utilize it for his task. Similarly, there is different encoding services. Also, we have data services. This is again very important. I want to search the data. Suppose now here this actual data security aspects are also over there. Let us say if there is certain data which is unclassified, which can be shared with all, so that I can implement those data sets also as a particular service. In OGC, we have web coverage service, WCS, for the raster data set. Whereas for your vector data set, we have web feature services. Okay, so raster, the satellite images or the maps are there. So we have coverage services. Whereas for the boundary, road layer or some point layer, we have the web feature services. These allow the data to be downloaded at the client end. We will see some example also later on. How I can download the data. Let us. I was talking to you about the boundary, village boundary. Can I get it? Can I? Yes, data set is also available as a boundary where vector data is available, which you can download of yourself. One separate session I have for that also. We will be covering more into that now. Portrayal services, web map service. Suppose I don't want to share the data, but I want to show the data. Advertisement करना है only. Okay. So only map I want to show. Like the land use map you were saying. I have not in the Goan Geo portal. We are not giving the map. We are only showing the map. This is the land use map. You see it, utilize. You can use that map of your own with that information itself. Make use of it. So we have portrayal services also. Only the portrayal of the service, web map services, web tiling services. There are many other geo services also, which are solving one or the other purpose of the geospatial domain. Some of the common GIS servers. Earlier I told you some common web servers like Apache, Tomcat, and many things. Similarly, we have GIS application servers. What are those? One is Geo server, UMN map server. These are two basically open source web GIS servers. We have ISRO GIS server also, proprietary Apollo server also. So there are many application servers which solve the purpose of web GIS. Some examples of the client-side applications. How to develop those applications now. Web server is there. Now I want to present the data set to the client. How to show it? So we have different mapping APIs also for it. Like we have a separate session for all this. We will be covering this in the late coming session. Open layer, D flat, D3, polymap, modest map. These two we will be covering. And now you see there HTML and JavaScript. These are the important programming languages or the scripting languages we can say, which are used for a web GIS development. So tomorrow we will be having one important session on HTML only dedicated to HTML and JavaScript, so that you have an idea of how the web mapping can be done in the web GIS in the web environment. For example, if I am showing you later on, we will cover to this example. These are some of the mapping of the today's in the today's environment. How can I combine the data from each of these sources to answer my questions? Okay, how I can do it? The web service concept is there. Some data is available over here. Some data is available in this portal. Some population is there. I want to take data from all and do some processing. Can I do it? Yes. Your web GIS processing services or the data services, they are allowing it right now. I can do the virtual reality in the web GIS environment is emerging. 3D processing we can do in the web GIS. Simple like we have in the Goan Geo portal, we have implemented that 3D. The 3D implementation. One very popular library for this 3D implementation, 3D data over the GIS is the Cesium Globe. If I see it here in the Goan Geo portal, if you go over here, I can have in Goan Geo portal, we have the 3D data sets also. So this has been all implemented. We can see the 3D data sets over there. I will show you one important example of this particular web GIS, which we have implemented at IIRS. Okay, so it's a little bit of internet connectivity. Sometimes it takes the time, but you try to try to explore it at your end. If you see it here, the globe, entire globe is available. I am zooming into a particular place, and then let us take one small 3D visualization in this web environment. I am not having any 3D software with me, but I am only having a browser. This is on client. I am acting as a client now. Okay. Now you see it here. This is some Tihiri Dam over there. Now we want to access it here, and you have to visualize it. We are in the 3D environment, how the terrain looks in and around this particular dam. So we can see it here. For demonstration purpose, or sometimes there are tools or models also can be created on top of it. So there are many, these layers can be overlaid on top of it. Let me switch off this layer. I want to see administrative boundaries. I have switched it off, and if you press the middle mouse button, you can see this data set also. If you see it here, see how the dam looks like. So we have all the data sets, 3D data set as well as the vector data. Both the data can be overlaid on top of each other. If you see here, this is the dam here. This is one river going on Bhagirathi River, from Ringna River, and again the Bhagirathi River. Somewhere here, the dam is there. Let's zoom it further. If you see it here, so I can see the entire mountain. This is the new Tihiri city now. Okay, at this place. And if you see the dam is somewhere inside this particular mountain. So this is one example I was just telling to you. That can all is possible in a web GIS environment. Not only 2D, but we can perform a 3D applications also using the web GIS. So CZM Groove is one particular example, which one open one layer, one we can say not API, which is popularly used for these kinds of 3D visualization. It also allows some sort of analysis also, like slope map generation or a contour map generation. I want to do a hill shading, or I want to do a view shed analysis. Okay, from this point, how much area is visible? If I come over at this place, then how much area is visible to me? I want to perform some military, military operation, or sometimes a tower operation also. See, at this point, one tower I want to set up, and I want to see how much area it will cover. So this is all possible in the GIS environment also. Let us come back to our slides here. So this was the 3D visualization. That is also very much models we can create. Collaborative mapping and data services. This already I have talked about. So this is one. Again, OpenStreetMap. This is also very collaborative mapping and data services. You try to explore it. Although we have a dedicated session for this particular application also. So we can develop a national spatial data infrastructure inside within the WebGIS environment. Or if you see it here, there can be a user, the gateway, then we can have central government organization. So that interoperability I was saying. There are different central organizations, different kinds of state government. They all can be combined together. They can share the data together, whichever format they have. Let them keep the data in their format only. But due to this web services, they can be data exchange or process exchange can happen. Okay. Some applications, Bhuvan Geo portal, I have shown you already. One, how the services is going over there, and then this is again the same thing. Thematic services, which I show you. Now, one example I will show you from IIRS case study also. That was, let us say, recently we have created one portal for geospatial data analysis, geospatial data visualization. Basically, it was for geospatial data visualization for the Kumbh Mela portal. So it is, let us say, kumbhviewer.irs.gov.in. This is available in the internet domain also. You can view it. If you see it here, we were able to create this kind of application. This map you are seeing over here, we don't have this map. This map we have taken from the Bhuvan. Weather information. We don't have the weather station at our place. We have taken it from the MOSDAC. From there, so that information comes over here. Right now, it is not coming. Some error may be there. So, similarly, we have air quality information is there. I want the fog information. So it will come something like this: fog or no or rainfall. So there is no rainfall here currently. And let us say NO2. It will show the NO2 concentration also. So some of the parameters we have taken over here. Similarly, land resources, land use, land plot 2015-16. This again we have taken from the Bhuvan Geo portal. So biological richness from the biodiversity information system, forest type map. This is again from some forest information system. So now again this urban information we wanted. So we have taken this urban information also. So these all applications. And then now again some vector data sets also. Water quality information, amenities information. Let us say COVID test centers. So you can see it here in this particular area that has been created. Now, if I want to see the more information into it, yes, we can have that tool also over here. So it will provide me what is the value at that particular place. So this is called the pop-up information basically. You click it here, it will show you the pop-up information. What is the information at this particular location? So this was one small example, and we can have the layer transparencies also over here. So many tools are there which are very much doable, or they can be done in a WebGIS environment. So this is again one GeoName API. This I am leaving for you. You try to explore it. If you see it here, this using the web services, I want to search a city based upon a pin code. So we can search this kind of web service or the API, which will allow me to, I am just giving it here a postal code 248007. It is providing me the output of what is the city name at this place. Suppose I want, let us take one example over here. I want the elevation information at a particular place. So there are certain websites like search elevation based on latitude, longitude information. Control C, I'm just copying this layer over here. Let us paste it here. Let us say this is the latitude, longitude here. Now from here onwards, I will increase it also here. If you see it here, you can zoom it further. So that now, if you see it here, this is the information. Now, if I change this latitude, longitude over here in the address bar over here, let us say I make it 25. Okay, and latitude, let us make it 80. 80 latitude, longitude, and 25 latitude. So it will fetch me the altitude at that particular information. So this can be used with the help of your programs also, where your programs can call this information from different websites and you can use it. Now this was one, this is all in the basics of the WebGIS. Now we will break for 5 minutes and then I can take some questions on this session. Thank you very much.